All right, good evening. So let's get started. Make sure the microphone works properly. Okay. So does it sound okay from the behind? All good? Excellent. Good, so welcome to APSC248. So hopefully this is the right place. So my name is Yan Chao. I believe I have met some of you already in a retreat session yesterday. And today is the first lecture. So the classroom has changed a little bit, and they added a couple of screen edit here. Now it does actually maybe pose as a little bit of a challenge for me because when I teach, the camera, the screen might actually blocking my face. But anyway, so I think that's not that significant. You focus on this big screen edit there, right? Yeah. Today, the first lecture, the structure, what we'll do is I'll see a little bit about the structure of this course, some information, some expectations from me. And if we've got time left, and then we can continue to our basically formally the first lecture, which is a review on some concepts on vectors. Okay. All right. So this is a little bit about myself. I got my bachelor degree from Shanghai University in China. That was a long time ago. I got my both master and PhD degree from mechanical engineering at UBC Vancouver, and then joined UBCO in 2007. So I've been here for a little over 14 years. And I taught a number of courses already, and this term I'm teaching 246, 248, and those are the other courses listed over there are what I have taught in the previous years. So currently, I'm a professor teaching. My other title is Associate Director for Undergraduate Studies. So I often wear two different hats. When I teach this course, same thing. So I'm both your instructor, but also will handle some other issues that you probably would come across in other courses. So that's about me. This course, this year we have 3 lectures each week, 1 hour each lecture. Okay. So it's not very ideal time, 5 to 6, but it's okay. There will also be tutorials. You can click on the link. So everything I'm presenting here, by the way, they all be in the syllabus. I don't believe I have uploaded the syllabus yet, but I'll do that tonight. Okay? Yeah. If you click on the link, you'll find your tutorial section date and time. So please join one of the tutorials. And tutorial, I wouldn't say mandatory, but we often design a tutorial to help you to supplement the course material, help you succeed in this course. So the formality of the lecture is in person, right? And I will record the lecture, right? I will upload afterwards. The tutorial will be online, so I have already talked to the TAs. We have 3 TAs in this course. The TA will create the Zoom links on Canvas. So you click on the Zoom, you'll see a number of links. Okay? So those links corresponding to tutorial section, and you can join the tutorial by clicking on the Zoom. So I think this is the best under current situation. Right? Now for lecture, right? Hopefully my computer, I already started recording. So as long as computer technology does not work against me, and I can certainly always provide recorded videos. If for certain reason there's something wrong, I could recycle my last year's videos. So for this course, I've taught many years, many times. I do have my videos in the past year, even on the YouTube. If you look at it, you'll find it, right? So that's not a big issue. So, and the other thing is, for office hour, I'll talk about that too. Okay, we'll have 2 sections probably. Okay. Yeah. So that's the lecture tutorial. Any questions so far? Okay, all good. Okay. This is the name list of TAs in this course. We have 3 TAs. I appointed Hiba as more of a lead TA for this course. Okay. So she has taught this course before. She's very experienced, very dedicated TA. I think you're all in good hands in terms of the tutorial. Okay. The TA will also be in charge of marking assignments and quiz, which I'll touch upon that shortly. All right, before I forgot, due to the COVID, we all expect it's probably inevitable some of us will get sick, right, including me. If I got sick, the plan as school engineering is we, as the instructor, if your symptoms are okay, so you can temporarily transition to online. So that will certainly post immediately to let you know how you can access the online course. But that's temporary. Once you recover, we'll come back to in person, right? But if you get sick, of course, UBC policy is you need to isolate. So the recorded videos was supposed to provide an alternative means for you to keep up with the course material and not falling behind. Especially I understand for this course, I'm not real-time streaming, but there are students who are not here due to various reasons. Most of the probable reason is visa issues for some international students. So they can also catch up, right, with the recorded course material. But my understanding is we are still trying, all the students are still trying to come back, bottom line is this is very different from last year. I would call it hybrid type of learning. It's not online learning, right? Any instructor, they're not capable to deal with two things at the same time. So for any other courses, you should have this similar understanding here. All right. So office hour, I posted in the syllabus. I will have one in person on Tuesday, one on Zoom on Thursday. So the Zoom link is included in the syllabus. I think this is probably the best way for those who feel not comfortable to come to my office. They can join the Zoom right on Thursday. And I typically maintain an open door policy. When the situation is ideal, you can always call by to ask me questions. This year, not necessarily I will be in my office all the time, 8 hours every day, right? So, but if I'm there, if you happen to have a question, I intend to maintain that open door policy. So just not a door, and you can always ask questions. But of course, we have to adhere to some of the COVID rules, right? So I do have hand sanitizer and everything in my office, but we're not going to be too big about that, okay? Yeah. But if you wanted to shoot me an email 24 hours ahead, that really appreciate it. So we set up time, other than office hours, you can also come back, right? Yeah. So textbook, this is the Thomas calculus. Most of you have already had a copy from your first year calculus course, so you can continue to use that, right? So basically we're using the second half of the textbook, which is on the multivariable calculus portion. Now if you don't have the textbook, that's fine. Textbook is not a mandatory. Many students survive the course with my lecture notes only and some provided additional exercise. But of course, many of you are more comfortable to have a textbook in hand, to do some reading, to practice a little more, right, based on the questions provided by the textbook. So if that's the case, by all means, you could get any other calculus, multivariable calculus book instead of just Thomas' book, right? So they're all the same concept. So that's the textbook. Most important, the reference is the lecture notes, which I will post on the Canvas. They're typed lecture notes, so they should be fairly readable and fairly concise. Not as comprehensive maybe as a textbook, but they're coherent, and you read it, and you get the bigger picture, and you also get many examples based on the lecture notes. Videos on lectures, I cover that. The TA will also provide the videos for tutorial, so you should be okay even if you missed the tutorial. Okay, so your course policy. Last year those policies really they don't apply, but now we're getting in person. so most policies will apply, right? So please turn off your cell phone when you are in this classroom. Technically, you should focus on this course. If you come to this course, you're not supposed to do any things not related to this course. We're not going to have any midterm actually, so that third rule is not going to apply at all. Okay? But we'll have quizzes though, right? We'll have assignments, okay? So make sure you adhere to the deadlines for the due days for the assignments. And if you miss the due days, this canvas will be automatically set. You get a 0 after a certain amount of time, right? So assignments, we'll have about 8 to 9 assignments. Right? Dr. Lucas and I teach this class. We're both pretty old-fashioned, so we believe practice. It's a math course. So math course means you have to practice. If you don't practice for a math course, just listen to a video, just watch, listen to me lecturing, most probably won't work. So you have to spend some time practice some questions. Right? So whether you practice together with your friends, I don't mind, as long as you don't present identical copy. Okay? That's what we will actually call your name or call you to my office. Okay? So you can work together, but you should produce unique copies of your assignments. Okay? You don't need to use, actually I said use engineering paper, but you don't have to, because assignments will be given on Canvas, and once you finish, you write clearly, you scan, you upload on Canvas, right? So we save ourselves the Dropbox hassles. And TA will also grade it online. So my expectation is you should write, hopefully, if the question is very short, maybe 2 questions per page. If the question is long, then maybe just 1 question per page. And try not to cram everything in a very small font. Try to make it readable, clear, readable, right? I know some people write very neat. However, the font is very small. Okay, it will pose as a problem for the marking. Even that's not a good practice, for midterm or final exams, right? So make sure you write it a little bit bigger and a little bit clear and readable. So it doesn't matter whether it's on engineering paper or anything else. Some of you have a tablet. I know some of you work on tablets. You copy, you take a snapshot of the question, and you start solving the question right underneath the problem. And I'm absolutely fine. You use a tablet, you use a OneNote, and then you convert it to PDF, you upload. That's absolutely fine with me, okay? The Canvas is our major assistive tool for this course. Okay, so everything will post on a Canvas, okay, including everything listed here. Now I do have my YouTube channel here. Because I'm recording my screen instead of using a Zoom, right? So I will actually upload this video to YouTube and then share the link on the Canvas. The other way of assisting is email. So you can choose to email me through the Canvas inbox. That will arrive at my UBC email indirectly. Or you can also choose to directly email me to my UBC email. Okay. The UBC policy, privacy policy, is that you should use your UBC email instead of your personal email. And I'm not supposed to share any private information to non-UBC sanctioned email. So anyway, same thing. When you're receiving official messages from UBC or school engineering, they arrive at your own UBC email instead of your personal email. Okay. So for assessments, we actually, for exactly the reason that some students may not be able to come here during the midterm season, so we decided to get rid of the midterm, okay, and replace the midterm with some quizzes. Okay. So a number of quizzes still yet to determine, maybe 5, maybe 6. Right? It's not going to be too many. And we also have assignments, as I mentioned. Right? So these two together will account for 40%. That's a relatively larger percentage. Okay? Now the quiz will be online. So when there's a quiz next week, I will let you know. And the quiz will be posted. Most probably the short answer question, one question only. You probably will have 1 hour to solve that one question. And my philosophy is to encourage you to learn. So my quiz, I also actually treat my quiz as more of an exercise. So you will see my announcement. The quiz is actually open book, so you can discuss, right? You can actually solve in a more openly, less pressured type of environment. Now that basically means most of you should be successful in assignments and the quiz. But in order to maintain the balance, the actual academic performance, right, your true reflection of academic performance. So we have a final exam, which is relatively larger percent, 60%. And the nature of the final exam, you will see my announcements. It's not accumulative, but it's very, very comprehensive. Basically, the final exam covers everything you learn from the beginning to the end. So I usually don't say it's cumulative, but in this case, since I don't have midterm anymore, so maybe I should call it cumulative, right? So I do have a rule for final exam, which is you have to pass the final exam with at least 40% in order to pass your course. So even though your overall percentage is 60%, but if your final is 35%, so you'll be in trouble, right? So I think the point here is basically, as an instructor, if you can get over 90% or almost 100% in the homework and the quiz, then you should not have any trouble with this final exam. Okay. Now, if you get very high percentages in the other two, but unfortunately you get a really low average in the final, well, there's certainly sometimes there's some reasons, but most probably there are some other reasons that you didn't really put your own effort into the other two assessments. Okay. So that's my heads up to all of you, right? My course is not really try to give you a hard time. If you ask around the senior students, the final exam are exactly going to be, well, now you have midterm, but final exams are going to be very similar to questions presenting in assignments. So you just have to practice. If you practice, spend a little more time, and I can guarantee that you will be okay with the final exam. Right? Of course, the pressure is there, but it's not like the kind of question you will never think in the final exam. Is that clear? Okay, good. So what do we learn for this course? Right? I actually really like teaching this course, okay, because calculus is fundamentally a very abstract concept. But from this course on, or in particular within this course, and you actually will start to realize there's some really fun stuff that you can reflect, you can actually see out of a boring and abstract formula, right? So this course, that's why I particularly like to teach this one here. You know, we're going to cover vectors concepts very briefly, just review that. We're going to cover lines and planes in 3D space. Okay, so what are the equations for lines and planes? And we'll also cover a function, but at this time it's called a vector function. Okay? And we'll also do, how do we do calculus of vector function? So that includes derivative. It also includes integrations of vector function. Okay? Multivariable function is the next step. So there's a vector function, there's a multivariable function. Okay? There's also multivariable vector function. Basically means your function is not just one single variable, it's going to be a function of multiple variables. And you're going to learn essentially what does multivariable function look like. You know, there's actually very fancy graphs that I can present it to you for multivariable function. Now, what can we do with multivariable functions? So that's the next step. You'll learn a little bit about optimization, essentially giving a multivariable, what's the mean and the max of a multivariable function. And how do I find that mean and a max? Okay, there's a particular technique called the Lagrange multiplier. And then the last two bullets there are particularly important for those of you who are interested in electromagnetic system, who are particularly interested in fluid mechanics. Okay? The concept of divergence, curl, gradient, okay? And the last one, the divergence-Stokes theorem, will set up a stage for your third year courses. Okay? So there's a very important concept. As a matter of fact, I often say that the last bullets there are the highlights of this course, which will happen most probably in the last 2 weeks of this lecture. Highlights basically means, as you will see, the last bullets there essentially make use of everything that you learned prior to the last 2 bullets. Right? So that's how coherent the structure of the course material will be. Right? So it's not like here and there, and there's not related. So this is the reason I kind of mentioned, why the course content is particularly important to engineering applications. You will see this concept, multivariable calculus, in numerical analysis, fluid mechanics, engineering optimization, and engineering electromagnetics. Okay. So I think by the time of somewhere in the middle of the term, you will realize, this is some course that actually math could be fun. So I often, throughout the term, will mention this one. This is your journey of calculus for engineering student, undergraduate engineering student. You start with the straight D, and you have seen this already. We call that differential, okay, differential operator. So if you D something over another variable, and it becomes a derivative operator, right? But the single D is called a differential operator. Then the single D will go into the curl D, which is what we're going to cover in this class. We call the partial derivative. Okay? And then the partial one will get into that inverted triangle. Yeah. And that one has some particular meanings. Now stay tuned. We're going to cover that. So that's what we call the journey of your calculus will actually end in this course for your undergraduate study. Okay? Of course, there's much more for calculus in many other areas, but for undergraduate studies, your journey ends here. And I borrowed one of the pictures from my previous students, and they posted outside the classroom for the final exam. The question is, will you reach the summit? And they put my face there, but actually they put the student. It's you. Will you? I already reached the summit, right? The matter is, will you reach the summit in this course? But you will be fine. So how do I succeed in the class? It's very cliche, I've shown this in so many years. Only 3 things you need to do before, during, and after the classes. So, this probably applies to any other classes that you're taking. Right? And a few more tips, for this course. Not just for this one, I think it's probably for every other courses. Organization skill, time management skill. We see this so often to our first-year students, right? Learn to take good lecture and tutorial notes. I'm a strong believer, you learn better by doing 3 things. So you listen, right? You listen to what I say, and you write at the same time. And if you could, and maybe you can recite some of these things to yourself or to other your peer or your classmates. When you're listening and writing at the same time, you're stimulating your brain and understand a little more. And when you're reciting it, explaining to your friends, you're actually functioning as a teacher, like me. So you're actually putting your own thoughts into how you can explain it, especially in a study group, right? So that will give you a better understanding, much deeper, sometimes causing what we call critical thinking, right? The process. Most important, the way I see, of course, we always have students feeding the class, right? And if you ask around, often the answer you get is, well, I just couldn't follow the class anymore, somewhere in the middle of the term, right? Because I've been busy with this and that, and by the time I realized, I couldn't follow the class anymore. So that's what we call procrastination. So, that really I can't do much about it. You have to deal with it, right? You have to ask yourself, am I following the class or not? Practice is the other thing that I keep saying. This is a math course. If you don't practice, I'm not sure how you can succeed. You have to practice. Even practice in multiplications, right? That's part of the reason. Understanding is the ultimate stage of learning, fully understanding it. But initial learning never be able to reach that.
Of course, there are some really smart students, some student who already have some knowledge about the content, and then they can understand right away, right on the spot, right? That's perfect. But I always encourage, if you can't understand right away during this class time, so the next best, which is let's memorize it first, right? Math is formula, always about a formula. So you have a formula. How do I use the formula? Do I understand what the meaning behind the formula yet? Maybe not. So if that's the thing, that's fine, right? So that's the next best thing. You memorize, you practice, and guess what? And then after a couple weeks, when you look it back, and all of a sudden you realize, oh, that's what that formula is all about, right? So that's what I think is the two things you should. The worst is you give up. That's not what we recommend. Yeah. Now, if you're falling behind as an instructor, as a TA, our responsibilities are here to help you with your intention to catch up. I have had so many students in the past, thousands of students, right? I really appreciate some students, and I have to say they're not the smartest student, but they are very dedicated students. When the situation is ideal, I had a student who just so persistent, just come to my office every time, asking for questions, me to explain it. Of course, it does take up my time, but you know what? That does help the student, right? The student eventually succeed in the class. Maybe not getting 90%, but the student can get really decent grades given their foundations. So I think you should be there. You should be like that. If you don't give up, I don't give up. Okay, let's put it that way there. Okay. The last piece of quote always given in this class is I really like this one here. Abilities what you're capable of doing, motivation determines what you do, attitude determines how well you do it. So I really sometimes look at the attitude. Some students, you probably don't realize when you're working in the company in real life. I think often in time they don't really look at your GPA, right? They look at your attitude. So that's essentially a snapshot of this class. My expectation fairly clearly listed, and it's up to you how you can. What happened to? Okay, yeah. And I will provide as much resource as possible from my side. Right? It's up to you how to use it. Okay. Any questions so far? All good? Yeah. Good. So we still have, technically about 20 minutes. So this is where I'll start formally the lecture. Okay. My lecture style, as you probably will see, I'll use my OneNote. So I'll write. Okay. And you can always write following me. As I said, if you don't feel writing, you feel like sometimes my writing is a little bit too fast, that's okay. So you could stop writing, just listening, because I will post my lecture notes. I will also post these written OneNotes there. Okay. So, oops, sorry. All right, so this is a little awkward. I'm not a tall guy, so I'll try. I'm still here. Yeah. All right, so let's continue. Let's start with the lecture here. Okay, the first part of the lecture is today, maybe also Friday. Today, Friday. Yes, we'll finish some of the important concepts on vectors. Okay. So first, definition. The definition of vector is very straightforward. Essentially, there are two key components in the definition. One is what we call direction, and the other is what we call magnitude. magnitude, sometimes we also call it length. So if you have a vector, you want to define a vector, then you need to provide these two information, the length or the magnitude and the direction. And the other important, very important, you need to always remember is that vectors are free. Free means if I have a vector here, you can move around in 3D space. You can move it to anywhere. Okay? Yeah. It's not really fixed, but you can always attach the vector somewhere in 3D space. Okay? You learn that in statics. If you have an object, you have a force applied to the object at a certain location, right? So basically, you're attaching a vector to the object at a certain location of the object. So that, but vector is still free, right? So which means I'm going to ask you a question very shortly, okay? So let's take a look at this quick question. Let's see if you have fully understand the vector concept or not now. Suppose that I have a vector here, which is A. So let's call it A vector. Right? And now, what I'm going to do is I'll make a copy of this vector A. All right? Make a copy means it's same length and same direction. But then I'm going to move that vector, the copy, okay, to a different location in 3D space. So now you got two vectors. Okay. You got two vectors. So the question is, are A and B the same vector or not? Let's raise the hands. So what did you say? Okay, excellent. Yes. They are the same. Why did you say they are the same? Because? Exactly. Right? Because the definition is satisfied. Both A and B has the same length, has the same direction, although they are at a different location. But as I said, they're free, right? They're allowed to be free. Okay? So basically, you apply this definition strictly, and you arrive at a conclusion that they are the same vector, okay, even though they are at a different place. Okay, good. This is actually quite a tricky. Sometimes I ask this question to my own kids and who's in high school. They tend to say, because when you have two vectors at different locations, they tend to say, no, they are not the same, right? Of course, when you have two different things at two different locations, they do appear to be different. Okay. So now comes to some of the notations, how I write the vector, how I manipulate the vector in this class. So basically math notations, how I present a vector. It's not universal. Most probably, I would say this applies to this course only, but we should be consistent, so you should write the same as me. And of course, it may not be, and that's annoying every time it shuts off itself a little bit. Yeah. But if you go to a different math class, that math teacher will probably actually write it slightly different, okay, just to be aware. So let's say when I have a vector, I write it like this. So A equal to, this is called what we call a half bracket, A1, A2, A3. So what I'm writing here is a 3D vector, which has 3 components. And you can use a comma to separate the 3 components at here. Okay, so you can see from here, I am writing a letter, and then I'm also having a so-called, this is called the harpoon, basically half an arrow on top of this character. Okay. So that indicates this is a vector. In your textbook, it actually uses bold letter to indicate a vector. But when I'm writing, I can write a bold, right? So this is basically an alternative, indicates this is a vector. Now some people will actually use a full arrow on top, which is okay, right? I'm just seeing myself writing a full arrow, right? So it doesn't really, that doesn't have any difference at all, okay? Yeah. As a review here, this is half angle here to note this is a vector. As you're going to see next, if I indicate a coordinate, I actually will use a parentheses instead of half brackets. Okay? Yeah. So this is indication is a vector here, right? And the other thing is, some students say, oh, I've seen some textbook using the so-called column vector. So basically, some textbook write a vectors like this: A1, A2, A3, using this sort of a bracket, okay, square bracket, and then with A1, A2, A3 written in a column. This is absolutely fine. Okay, as I said, it's just a preference how people present the vector. But in my class, as I said, I am presenting the vector in this way because I will quickly, if I write everything in column, I have to scroll very fast. Yes?
Is there a difference between writing it the way you write it and using IJK notation?
No difference. That's actually my other way of indicating a vector using I hat, J hat, K hat, which you will see. Yes, excellent. As a matter of fact, if you do a little Google, there's a turf war between mathematicians. Should a vector be written as a row vector, or should a vector be written as a column vector? I think the column vector sometimes edge out. Okay, so and now I'm going to come to that the unit vectors next here. Okay, but let's keep this reviewing and also the notation wise in hand in hand. So let's say this is a part of review now. Let's say if you have a 3D coordinates x, y, z, and if you have 2 points labeled here, P and Q, and the point P has a coordinates x1, y1, and z1, and point Q, x2, y2, z2. Okay. So now you can see I'm introducing the concept coordinates. I'm introducing the way how to write coordinates, which has this parenthesis, right, on both sides of the actual value of the coordinates. Okay. So if you can always create a vector now using the 2 points in 3D space. As you have learned previously, I'm sure you know that, you can write it as a PQ. So immediately you can see I'm writing a half arrow on top, indicating this is a vector. I'm writing a PQ because this is a vector from P to Q. Okay? So you already have the coordinates of the point P and Q, then the created vector PQ will essentially be the coordinates of the Q minus the coordinates of Y, of P. Okay. So this is your resulted vector PQ. Surprisingly, this simple concept on creating a vector between 2 points, every time when we have a midterm or quiz, there are always a few students making a mistake. So the subtraction becomes the other way. Now the problem is, once you do that, your following results pretty much is all wrong with a sign difference. Right? So math is very rigorous. You can argue, oh, I just have a sign difference. But to me, it's completely wrong. So we have to be rigorous right from the beginning, right, in terms of how we write and how we calculate. So you can calculate the magnitude of PQ, okay, which in my case, in my class, I use 2 straight bars, okay, sandwiching this PQ to indicate this is the magnitude of the vector. Okay, so that's my notation, all right? Also my notation in the lecture notes. Of course, you probably will see notations for magnitude in other references as 2 bars. Okay, this is actually probably most common, but I just want to write 1 less bar, okay? So make sure you understand these are same thing, essentially, right? So if you have a magnitude, if I do calculate magnitude for this particular vector, that's actually pretty straightforward. You square each component, and then you sum them up, and then you take the square root. Okay. Then you get the magnitude of that vector. So for example, if I use this one here to calculate the magnitude, then I will put the bar sandwiching this vector, then that becomes a1 squared plus a2 squared plus a3 squared. So now I'm introducing basically both the sort of review and a notation. Right? So next concept I want to review is unit vector. Okay. So unit vector, by its name, right? It's very straightforward. The vector's length is unit. Unit means 1. Given a vector A, then its unit vector, and we write it as this, A hat. So A, on top of A, we use a hat symbol. Right? So we call it A hat. And A hat is defined as the original vector A over its magnitude. So that's the definition of a unit vector. If you have a vector given, you want to find out it's a unit vector, what do? You apply this formula here to get the unit vector. It's still a vector, but its length will be 1, right? So if you calculate the length, and it's going to be 1 because the nature how it's defined. Most important in this class, I think you need to understand is we often talk about directions of a vector, right? So when we see directions, so direction is represented by unit vector. So if I say the direction given by certain vector, then that information direction basically means you calculate the unit vector and then you get that direction information. Okay? And you can argue, well, I have a regular vector, the vector pointing to a direction, right? Can I use the vector to represent the direction? You can, of course, because the vector does point to the same direction as the unit vector. But it's just for my next purpose, specifically, when we see direction, we're actually saying the unit vector. So now I'm actually circling back to the definition of vector. So if I have a vector here, right, then I can calculate its magnitude. I can calculate its unit vector. Then I multiply the magnitude and its unit vector. That gives you back its original vector. So what you really have here is, right, this is basically a scalar quantity, the first term. And then the second term here is a vector quantity. Right? And the first term here is the magnitude, and the second term here is the direction. Right? So that line up very nicely with the original definition for vector, which is what? The two components, direction and magnitude. Okay. So you can always, whenever you need a vector information, so this is where actually now imprint your mind. If I'm required to find a vector, you're actually required to find two things. One is the magnitude, the other is the direction. Okay. So there are a few other things that should be pretty straightforward. I'm not going to spend too much time to do reviews. Basically, how do you do vector addition and subtraction? Okay. So I want you to look at the lecture notes. Addition, subtraction, basically you just manipulate the components of the vector, right? You add or subtract, it depends on the need, on the question. Okay. Any questions so far? All good? All right. So, but there are two quite important concepts of vector is I need to do a review. Number one is a dot product. Okay. So I'm going to actually introduce some concepts or applications into these two things. The next one will be the cross product, okay? Yeah. So let's see how far we can do. Definition first. I'm going to define two vectors first. The first vector is A vector. The second vector, let's call it B vector. Each one has component A1, A2, A3, and B1, B2, B3, respectively. When we do dot product, we put a solid round dot between the two vectors and indicate that this is a dot product. Because you learn multiplication. Product basically means multiplication, right? 2 times 3. But you don't write 2 times 3 with a solid round dot between because they are now vector. But you put a multiplication sign in it. But now we're talking about multiplication of two vectors. How do I properly indicate that? That solid round dot indicating this is a multiplication of two vectors. The simple formula for multiplication of dot products, for multiplication of two vectors is this. So you could, because I already have the components listed here, so typically, basically, you write it in a very compact form. This is summation sign AI times BI, and I goes from 1 to 3. So of course, if you write it out, it's A1, B1 plus A2, B2 plus A3, B3. So that's how you properly calculate a dot product. But that's, of course, that's based on your knowledge of A1, A2, A3, and B1, A2, B3. Yes, go ahead. Sorry, come again? What symbol is on top of the sigma? Oh, 3. Number 3. Yeah, because I only have 3 components in here. Yeah. Okay, is that better? Okay. Now, of course, if you look at the results out of here, I think one important thing that you should memorize forever, absolutely forever, is that this is a scalar. Okay. So it basically means dot product will present a scalar value. Maybe it's a 3, maybe it's a 2, maybe it's a ridiculous and a large number, but it's a scalar. It's not a vector. Now, alternative, okay, some applications of dot product here, okay, some applications. So, for example, if you're required to calculate the magnitude of a certain vector, and you'll see that this is equivalent to this. So essentially, what's happening here, you calculate the dot product of the vector itself, and then you take the square root of that, you get the magnitude of this vector. So that's sometimes this actually comes in handy in proving some theorems. Okay, yeah. So you get if you tried it out, you get exactly the same results as previous what we have written. A1, A2 is squared, and then take a square root. Okay. Yeah. So this is what sometimes I call it algebraic definition of dot product. The next alternative definition of dot product, okay, and I probably actually call it geometric meaning of dot product, which is A dot B equal to absolute value A, magnitude of A, times magnitude of B, and then times cosine theta. Okay. So graphically, basically means if you have a vector B here, if you have vector A over here, and then the angle between the two vectors is theta. Okay. So you plug in the necessary information over here, you get an alternative formula for calculating dot product. Okay. Now, particularly the theta value here should be between 0 and pi 180 degrees. Okay. So it shouldn't have a 190 or something. Right. So now you might argue is, why do you draw the A, B here like this? Right? What if A is here, B is there? Back to the original, vectors are free, right? So even if you're presented two vectors like a million miles away from each other, just bring them together. But when you bring them together, you are not changing their direction. You're not changing their magnitude. You just bring them together and touching each other. Okay? And then you can apply this formula to get the dot product. And this nicely brings to maybe alternative information. So let's say if you have A and B given, and you're required to find the angle between A and B. So then you can calculate the theta value by using this inverse of cosine. Okay? Yeah. Good. So let me finish just one more line here and then I'll stop. I have a special angle, which is when theta equal to 90 degrees. Right, so now you can imagine in your brain, so if I put two vectors touching each other, and then an angle between the two vectors are 90 degrees, so this literally means what? These two vectors are perpendicular to each other. Right, that's a very special configuration. And when this is the case, you calculate the dot product, you end up with a 0. Okay? So basically, dot product 0 means A is perpendicular to A, or the other way around, the same thing. And that's a very nice feature you can make use of to test what is the geometric configuration between the two vectors. Okay. So I'll stop here. In the next lecture, I'll have exactly the important parts to do the vector projection, and making use of the vector dot product. Okay, any questions? All good? So have a good night.